start the stream this time.
Okay.
Alright, so we have a pull request open for the generator expressions. I see Stan had some comments on it. Probably pretty good comments, so let's address those first.
Great. Yeah.
So that we don't get that many conflicts on the new branch. So let me pull if there are any GitHub. Oh, so what happened here? Do I have different commits? Reword the generator expression section, apply suggestions from code review, and I'm here on 0655B. Okay, oh, I'm probably need to specify where exactly to pull from. Yep, right, so now I'm here. I should probably merge in the main branch as well, just to make sure there are no conflicts with the current state of things and get the latest CI configuration and so on. So I don't know if we looked at the outdated ones last time or did it offline, but they're probably not that important now. Here the enclosing parentheses can be embedded with in calls with only one positional argument. Yeah, I think we talked about this one last time.
Yeah.
You remember? Okay. So I'll just apply my approved change. And here, yeah, so passing in an iterator to make all the example or all the equivalents less rough. I guess that's a good thing to do. So let me commit this change. For more precise wording for only one positional argument. And so for all the places where this says something is roughly equivalent to blah blah blah, the iterator from this range is actually created at the point of the call. So this should be iter, and this should probably be named iterator. Right, and we get to make that change. Oh, we only have that here. We don't need to make that change in the previous ones, like in the comprehensions, which also have this roughly corresponding thing, because here the function gets executed at the point where it's called. Right? With generators, the body gets executed later.
Later? Or oh yes, I see.
Yeah, well, yeah. So where does this where is this relevant? If I do this, I get my generator to make use of it. I probably need to do a for loop. Look at this. So this is a generator of squares. Now, where this iter is relevant is if instead of something iterable here, I, for example, have a custom function. Right, so I would have something like custom number iterator, which would have a next method. This started on 0, let's say, and then we have an end. Right, so hopefully this will be the same thing as range 10. Yep. Ah, no, it's not iterable. Okay. It's not iterable because I don't have an iter method. So yeah, now we get the same thing as before. Does this make sense?
Yes, so far.
Now if this iter raises an error or is missing, you get an error here.
Custom. Okay.
Right? Which is the same thing as if we replace this with the supposedly equivalent expression, which is this one. Instead of gen, I'll call it iterator. Right, so now we have.
Better
well,
error message.
no, it's here.
Oh no, I see. Okay.
Right, so we get this error right away. If I put in back at the iter, which I should have just commented out, and that's just the same thing, and thing. And what else? So if I raise an error here, then the iterator gets made, but the error gets raised when I go through the for loop. the same in both implementations. So anyway, where am I going with this?
I think you just wanted to show where things were running.
Right, so this change then makes things more equivalent. Is it worth the complexity? I guess it is. And yeah, iterator is immediately created for that iterable. Right. Oh yeah, there's now one thing where these two are not equivalent, because I think this iter, like the iterator is created, the iterator for this is created just once here. But here you have an iter, and then the for loop makes an iterator out of that iterator again. Does that make sense? For example, if I have
For loop, okay, yeah. These are good examples.
Like this returns a custom number iterator. Oh well, no, I can just add a side effect to iter, right? Right, so with this, the iter is called okay, let's comment out the ones we don't want. So let's comment out this one first. So here, iter is called for custom number iterator, which is then basically passed to the internals, and when I then iterate through this, no more iter is called, right?
Yeah. Yeah.
The other way around, I'm calling iter here, so that's this one. But then in the internals, I have a for loop here, and the for loop implicitly calls iter on anything it gets here, right? That's why iterators should return themselves, because the for loop will create a new iterator. Well, basically call iter on whatever it gets, and if it's already an iterator, it should return itself, right? So these two things are not exactly equivalent, but this is, I guess, a smaller issue.
So are we comparing calling an iterator from within a generator to calling an iterator?
Yeah, we're comparing this and this.
That, okay.
So the documentation we're adding says that these two are roughly equivalent.
Right, okay.
Which is correct, but the more equivalent they are, the more useful the example will be.
Right, I see. Okay.
So yeah, putting the iter here does not make it 100%. On the other hand, the specific or the documentation or specification, I guess, for iterators says that they should return themselves. So this other call shouldn't do anything bad. guess the problem would be if the iter function did something, right? So if this, for example, advanced the state, then these two things would give you different values. But it's close enough.
So yeah, so they produce the same result. Are they different?
They produce the same result if this iterator is well behaved, let's say.
Okay.
If getting another iterator out of this iterator returns itself, which I think is specified somewhere. You should do this.
So do we have to consider that principle of there should be preferably one best way to do things? Or are we giving people options that they don't need?
No, we're explaining things.
Okay, explaining, okay.
We're saying that this means this.
Oh, okay. Okay.
And there's a difference that we're leaving out. I'm trying to convince myself that it's okay to leave out the difference. Yeah, I think it is. Alright, so next, the iterator is immediately created for the iterable as a word that should be left. So the iterable expression of the leftmost cross is evaluated immediately. I probably want another example here. Like if you put in a non-iterable object like this, you also get the error right away. Something like this.
Yeah, that's better.
Do we need this? The next paragraph doesn't talk about errors, but the examples also use errors to kind of illustrate where the logic, like when things are evaluated. There a different way to say creating an iterator from something? Maybe I'll look at the iter function for inspiration. Oh, here's the documentation for iterator objects needing to return themselves from their iter.
He doesn't like the word created, is that it?
Yeah.
Returned?
Well, not really returning anything.
No, okay. Added?
Maybe we can say after this expression, the expression is validated, an iterator is created from the result as if iter was called on it. Errors.
An iterator is produced from the result?
I guess so. This is what I want to say. Any error raised when creating the iterator is also omitted immediately, so that this example makes sense. And I want to simplify this wording because it's 3 words and it's too long, but I can't think of anything, so I guess it's fine. It. All right. So what's the difference? We call iterator here, rename the argument to iterator, and say that the iterator is created from the result immediately. Hopefully that'll address the review issues. Does that look good?
Yeah, I think so.
Is there a better way to word this?
Gosh. Nothing obvious. I'm sure somebody will have a suggestion, but
probably not.
Yeah, probably.
Who reads these?
Yeah, right.
All right.
In the source, so there's a paragraph there that says the iterable expression in the leftmost for clause. The word for has a funny little, I wonder if there's like a missing tick mark or something in the source. Do you see what I'm saying?
No, that's like the keyword for.
Oh.
That's intentional. Right. That's monospace.
No, I understand. I thought that for some reason it looks like the letter F is bold, but maybe that's just my screen. No, okay, that's just my screen. No worries. Okay. Yeah, okay.
All right. So then we go on to the yield expressions that we did last time, right? Merge in that branch. And because we're building on top of that, we need to follow up on any wording there. Build that, and look where we are. Here we are. Okay, build. Right, so we added some text for the some general text about basic yield expressions, and then we started covering the complications. Let's see, there's a to-do here. So note the call. So, where are we? Commonly, iterators are consumed via for loops. Which implicitly let's keep this singular. Only an iterator is consumed via a for loop, which implicitly calls next at the start of each iteration and handles stop iteration. Note the call to generator function. This creates a new iterator which yields a new set of values. I can hear you. Hello?
Sorry about that. Let's define a term here. So if the function, meaning the generator function here, returns before a yield expression is encountered, either with the return statement or implicitly at the end of the function, the generator raises a stop iteration exception. So we call such an iterator exhausted. I don't think we have a term for that yet. Probably should have a term for exhausted, right? See, it's used a lot in the docs for some reason. Do all uses of the word exhausted refer to the same thing? If they do, we should probably add a term, right? Yeah, for sure.
There's a lot of them. So this is memory exhaustion and C-stack exhaustion, not relevant. Exhaustive list, not relevant. If that iterator is exhausted, there we go. So that's collections.rst, and we need to link that term that we'll be adding shortly. Okay. If the iterator indicates it is exhausted, again, so this client until the iterable is exhausted. All right. So apparently people are using this term, but we're not really defining it anywhere. Let's fix that. Iter tools. Okay. Exhausted. Iterables are exhausted. Exhausted. The iterable is exhausted. Exhausted has a variable name. Input is exhausted. Yeah, iter tools has a bunch of this. Probably want to search and replace here. So batched. The result is yielded as soon as the batch is full or when the input iterable is exhausted. Yep. Chain. Returns elements from the first iterable until it is exhausted. Then proceeds to the next iterable until all of the iterables are exhausted. Compress stops when either the data iterables blah 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 have been exhausted. Cycle when the iterable is exhausted. Here we don't change anything. If stop is non-iteration continues until the input is exhausted, if at all. Zip longest iterable is exhausted. Round robin, this is a code comment. And we're done with this page. Next up, OS. Okay, scander.close, interesting. Version changed for the same thing, we don't need to change that one. Profiling sampling. Resource exhaustion, that's a different thing. Stab, not an exhaustive list. Test, exhaust as many code paths. Is this like tests for tips for writing tests? Interesting. Didn't know we had those. Exhaustive tutorial. Exhaustiveness type checking. Okay. Mock. If the sequence of result is exhausted until iterable is exhausted. Right, so unit test mock needs some references to this. Oh wait, no, side effect. Let's read a bit more. Iterable exhausted, okay. Side effect is exhausted. Let's not link this last one, because I think at this point it might not be an iterator. People should look at the or read about the previous ones first.
Stan says he just left a new review or a new comment.
Oh. So in this new agentic world, I'm supposed to execute the code that's left in the comments, right? Let's see, what does this do?
Oh God.
Ah!
That's a good okay.
Alright. There we are. Let's get this one in. guess we should try to get it into 314, right? If it backports cleanly. Let's see on that. In the meantime, there's disk volume exhaustion. Huge page Linux huge page pool exhausted. Okay. Popular thing. Non-exhaustive list. Exhausted, and this is the tutorial for the range function. In many ways, the object returns by range behaves as if it is a list. In fact, it isn't. It is an object which returns the successive items, blah blah blah, but doesn't really make the list, thus saving space. We say such an object is iterable, and this is linked, that is suitable as a target. Oh, this is a nice description of iterable objects, and we should link this exhausted control for. Data structures, comparing. So this is exhausting sequences. Sequences are iterables, I guess, but we probably don't need to like this term. Yeah, sequence objects use a slightly different protocol than like the proper new style iterators.
Okay.
So I wouldn't link this to the term that talks about stop iteration errors and stuff. Exhaustive list. Iterator is exhausted. Docs for the 4. So this is compound statements. Good. Built-in function. Next. Oh right, we need to cover asynchronous iterators. .rst. This is very close, so I'm not linking that. Iterable is exhausted. The iterator is exhausted. Shortest iterable is exhausted. This is a different bullet point, so I probably want to link that one. And that's it for this. Next, a built-in type has a non-exhaustive list. Changelog, I'm not going back through the changelog. Exhaustive test suites. Exhaust all input iterator. So the functional. Okay, the functional how-to has a few. This should be linked. This should be linked. But there's more about exhaust. glossary. Huh? Oops. To here. This is CAPI. Nothing here. Disk volume exhaustion. Iternext. Oh, CAPI. So when the iterator is exhausted, it must return null. It's a bit unclear. So let's clarify that it's here while I'm here. Okay, any more exhausts here? No. So what's new? What's new for 2.5 is probably not worth linking anymore. 3.5, 3.6, and that's it. Okay, so we linked all the references to iterator exhaustion. Now let's make the entry itself. A, B, C, D, E, X hosted. So what does that mean?
Oh, you said there was a nice definition a few pages ago.
Yeah, that was the tutorial definition.
Oh, I see.
Iterators.
Okay.
So like you don't know anything at all, and you want to get a general idea of what they are. That was this one. So the tutorial starts with the range function, which I think is pretty smart. So it covers 4 statements with lists, then with dicts. This is probably too advanced for this tutorial. And then it comes up with the range function and generalizes that to iterables. So in the glossary, do we have asynchronous iterators? Asynchronous iterator. Which phrases stop async iteration. Now, what does this already say? Iterator is an object representing a stream of data. It calls to the next method or passing it to next. Returns excessive items at the stream with no more data are available. Stop iteration exception says at this point the iteration object is exhausted, and any further calls to its next method just waits stop iteration again. Right. So yeah, this is nicely documented already. It is required to have an iter method that returns the iter itself. So blah 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 blah. This might be too much for the glossary, and it should be moved somewhere else. But I'm not fixing that one. I just wanted the term exhausted in the glossary. So let's add that to the upcoming commit. Oh, I linked it twice in the same sentence in itertools. Let's fix that. It's just wasteful. And we can finally go back to where were we? Expressions. So if the function returns, so I guess if the generator function returns before a yield expression is encountered, either this way or that way. The generator iterator becomes exhausted all further attempts to get the next value will raise a stop iteration exception.
It also occurred to me another option to create might be produce.
Maybe we should say using the exhausted.
Oh, nice, yes.
State here, call it local state. And that all local state is retained, including the current bindings, blah blah blah, instruction pointer, blah blah. So call this local execution state and use the same term down here. We say this example calls, let's view a word, This might be veering too much into explaining what iterators in general do. So let's
That's true.
put it in as a note. No, I don't like boxes. It's a note because it starts with note. I think that's fine.
Sure. Fair enough.
Okay. If the generate function returns before the yield expression is encountered, either which returns time power implicitly, the generator iterator becomes exhausted. All further attempts to get the next value from it will raise a stop iterator exception. Separation exception. Commonly, an iterator is consumed by a for loop, which implicitly calls next at the start of each iteration and handles stop iteration. Well, note that instead of reusing the exhausted generator iterator, this example calls generator function again to create a new iterator with its own local execution state.
That's that seems okay.
And here we can here we can make this a bit less wordy. So an iterator or asynchronous iterator is produced all its values to be exhausted. Further attempts to get the next value, for example, cost next, raise stop iteration or async stop iteration respectively. Which order? And maybe I can remove this as well, because we do link to the term iterator, which explain things quite comprehensively. Right. Okay, so that would be the introduction to yield expressions, which kind of turned into the introduction for generator iterator methods, or generator iterator functions. We should probably later move to a new page or something. Now let's get to complications. So yield statement is easy. You can do yield without a value. If that's omitted, we produce none. That's trivial. Valued of the yield expression. When using the basic iteration protocol, the value of a yield expression is none. The yield is none. I guess we should also say something about the parentheses. runtime, we're using the basic iteration protocol for next. The value of a yield expression is none. A different value can be given by using the generator iterator's send method instead of for or next. Generator iterator blah blah. Next. And that yields the 1, 2, 3, and then you say send different and you get different. Note that send with a non argument can only be used when the generator is suspended at a yield expression, not when not with a freshly created iterator that is suspended at the beginning of the generator function. Something like this. Generator function, you send something and just started. That's a nice term. Let's use that. Right, so that reworded this. If the value of the yield expression after resuming depends on the method, blah blah blah. If send is used, then something happens. Otherwise, it's none. Okay. Next up, we still need to say when yield expressions must be enclosed in parentheses. Probably can put this in the value of section. So yield expressions must be closed in parentheses except in here parentheses are not required. Here parentheses are required. So this is not a yield statement, is it? This is an assignment statement. Could also do this. 1, 2, 3, 4, 5, 6, 7, 8, 9. What comes after that? 8, 4, 7. And I guess this should have its own section, right? Use gen here. What call it generator function before, but we probably don't want to override that. Okay. So asynchronous generator functions. We probably want in a separate section, like in the current docs, but a reference to that separate section might go at the very start. Maybe in a box even, because there's a lot of text here. See how that looks. I hope you're all muted on your side, not on mine. So what else do we need to convert, reword? At runtime, when a generator function is called, iterator. Covered that. That iterator controls execution. Initially, execution is suspended. That calls about methods.
It might be my imagination, but it seems like your voice has dropped in volume.
Oh, really?
I don't know. Huh. Just a little bit. I don't know if you change your position on the mic, but because I just found myself turning the volume.
Is it better now? Let's see. Is it better now?
Maybe a little bit, yeah.
I don't know if this setting has any effect.
It's not a big difference, just a touch.
Is it better now? Actually, let's...
That does seem better.
Let's max out this setting, and it doesn't do anything.
not too much. Starts clipping.
Ah, I see. Okay, let's go with this.
Yeah.
Okay, this is all text that's covered above. Yield expressions are allowed anywhere in a try construct. Ah, this is interesting. So yield expressions and try. Yield expressions are allowed anywhere in a try construct. If the generator iterator is not resumed before it is destroyed, garbage collected, its close method will be called, allowing any pending finally clauses to execute. Guess that needs an example. For example, so if I have a generator function and it yields, or 1, 2, 3, and then we get to finally and print something, shutting down. I probably want to put this in a console, right? So def try, oops, yield finally shutting down. So if I do this and then make an iterator out of it, call next, and then destroy the iterator, and it'll shut down. Which is technically an implementation detail for CPython. probably needs some more or better explanation. Something like this.
Yeah, that looks may happen.
It's not really a detail I would like to get into right here when people are trying to wrap their heads around
yeah, exactly.
yield expressions, but it's good to point out that you shouldn't really rely on this. Alright, and then we have the fun stuff, yield from.
Oh, is that like a context manager?
It's delegation to a subgenerator. I think there's a syntax for delegating to a subgenerator in pep3 AA Python 3.3 added the yield from statement. So when yield from is used, a supplied expression must be an iterable. The values produced by iterating that iterable maybe we should say the values produced by that iterable are passed directly to the caller of the current generator's methods. So we would say it's directly to the consumer of the current generator. So we're trying to get away from calling the methods directly. Any values passed in with send and any exceptions passed in with throw. We haven't really covered throw yet, right? So after value of the yield expression, we should also say cover throwing exceptions into yield. generators. For later. So we've covered that now, so we can say an exceptions passed in with throw are passed to the underlying generator if it has the appropriate methods. That is not the case. Then send will raise attribute error or type error, while throw will raise the passed in exception immediately. Right? For example, do we have a nice example for this? Oh, there's a fun one. Oh, this should be yield, sorry. So, yield. I guess we should say hands up, hands down. We dance by yielding from move hands, yielding something like turn around, and then doing this again, right?
That's a very funny example. I love it.
Ta-da! All right, there we go. I don't know if we should make this into some actual choreography. And this one is an example of the easy of like the basic delegation. I don't know if you want an example for send and throw. Or we can just leave this as it is without an example, at least for now. I'll see how I think about that next week. Alright, so when the underlying iterator is complete, the stop iteration value attribute of the raise stop iteration instance becomes the value of the yield from expression. Ah! It can be either said explicitly when raising stop iteration or automatically when the sub iterator is a generator by returning a value from the sub generator. So this is probably a bit more important than send and throw. But
yes, I agree.
I don't have a good example for this one. Should we continue some kind of dance routine?
Yeah, I think so. Like maybe falling down or let's see. So let's see. Put your hands up. Put your hand down.
Yeah. So
Bow.
so this
Take a bow. I don't know.
yeah. So this subroutine should return some value to the
Right.
overall
The dance.
choreography. So
Right. Move hands. Put your hands on your hips.
yeah. So what would the result of move hands be?
Oh, I see. Move hands. Shake your body. Wave. The result. Point up, point down, or
Now we need a result from that function.
we see the result. Yeah, yeah. Move hands. So a result would be like the position of the body, or more like the gesture,
Maybe.
like say hello, like wave or something like that.
I don't know.
I'm trying to remember the step. Yeah.
So here's a non-dancing one. So we're trying to compute a sum from some values. And
okay.
for each value we print, we update the result. And print out something like...
oh, okay, added. Oh, okay, sure. Oh, that's nice.
this.
Yeah, of course.
And then we yield result. So this is called... What's this called in English? Like running sum or something like that?
Running tally? Total. Running total. Running total, yeah.
Running total, okay. Now that's a long way from dancing, right?
Yeah, no, but it's familiar. Maybe more so than the dancing.
Okay. Oh, and at the end we want to return result. Maybe we want to print before setting the result. So this would be this. We'll yield before adding. then we get the final result. Oh, that's silly. Maybe we should yield the messages. I should probably think about the better example here.
Should we do something with time, like now?
So if I add together, 1, 2, and 3, and then I do the same thing with like other values, and then I can print. This is a horrible example. That's not even correct. I do need to print here. We're not really using the intermediate values? No. Oh, I guess we are. So this will yield the messages. Right, so this will yield the individual messages from the trace running total. So delegated by the yield from.
Well, that's kind of cool.
And then it prints out. Oh, this could have been a yield as well, right?
Yeah.
But is this any fun? Really contrived. The dancing was better.
It was. Yeah, we could have like a so we could have like one a function of wave, which is your hands goes up, your hands go down. Another one is jump, where you step to the right, or whatever, and step to the left, or you jump up and then you yeah, I guess you don't jump down, but something where you have several gestures, and then you can say like take one step to the right, and then show basically like how many steps. I don't know. Maybe it's getting a little too contrived.
Yeah. Maybe the dance routine should be like find a partner.
Ah, there you go.
Where you look around and take a step toward, like if you see a person on the left, then turn left, and if you see a person on the right, then turn right.
Course. Yes.
If you don't see anybody, return false. And then the main routine would well, but it's also getting a bit contrived. Like the example will be huge. right?
Find partner, yeah. Oh, look around? Sure.
If, like, how do you use random? I haven't used that in a while. Random.random, okay. So if random is smaller than 1/2,
oh, there you go. Oh, sure. Okay, turn right. Otherwise, okay. Yes, that's found the person on the right. Okay.
right?
Cute.
Then we
Sure.
do something similar on the left.
I love it.
And which
Turn
is
left, yeah.
true. Otherwise, shrug and return false, right? And then the main routine would go if yield from find partner, then you would do something with them. Do a high five or something. Else, do a lonely jump or something. I'm still getting used to this console. Okay, so look around, turn right, high five. Look around, turn left, high five. Okay, is there a situation where it doesn't find a partner? No, here. Look around, shrug, and do a lonely jump, right?
Right.
That's a very complicated example, and I think we're kind of blowing past our budget for this section. This probably needs a bit of randomness here. Yeah, this is like half of my screen. And it's okay, so there's that yield from. So I was with yield expressions. From expressions. be enclosed. That's the word I'm looking for. This is missing some kind of introduction. I don't know. It's getting late. The code looks the part. We might need to scrap this entirely.
We could commit for sure. I mean, it's do you want to you want me to just put a little to do to come back to this example? A little reminder to do that?
I mean, that's where we are.
Or it's where we are. So okay, sure, fair enough.
So yeah, we'll come to this later. There's still some more details to cover. Probably won't yield from in like a separate chapter or something. And then there's the generator, iterator, descriptions. We'll probably need to move these out somewhere before we're done with this this pull request. It'll be a big one. Anyway, next part is coming up in a week. So see you then. Thanks for your attention.
Yeah. Great.